Your AC fan runs, stops, cools down and starts again. That pattern is more useful than the word intermittent. Record what changes first at the exact stop: the cooling call, control command, supply voltage, motor current, motor temperature, fan speed or system pressure. Different causes can look identical after everything has stopped. Their timelines usually do not. A typical split system has an indoor blower and an outdoor condenser fan. If air disappears at the vents, investigate the indoor air path and blower sequence. If the outdoor blade stops while the system is trying to reject heat, investigate the condenser fan circuit and outdoor conditions. Do not keep the unit running with the required fan stopped, switch it off and follow the exact equipment service procedure. First, separate a commanded stop from a failure. Compare thermostat demand, control board output, or contactor command with actual fan speed. If the call ends first, the fan may simply be obeying control logic, or an upstream safety may have removed the command. If the command remains present while speed falls to zero, move downstream toward supply, motor, capacitor where applicable, wiring and mechanical load. A fan that starts cold, runs until temperature rises, stops while the run command remains, then restarts after cooling can be consistent with a motor protector opening. That fingerprint identifies a protection event, not the root cause. Restricted cooling, excessive load, incorrect voltage or frequency, high ambient temperature, bearing drag, winding damage or the wrong motor application can all push temperature upward. Follow heat back to its source. For an outdoor fan, check the coil, grill, blade clearance and motor cooling path. For an indoor blower, check filter loading, coil condition, wheel contamination and system static pressure. Compare operating current and voltage with the exact unit and motor documentation. A protector should never be bypassed, it may be the only component preventing further damage. Some single-phase PSC fan motors require a specified run capacitor. A weak or incorrect capacitor can produce slow starting, humming, reduced torque, overheating and repeated stops. But this branch does not apply to every AC fan. Three-phase motors and electronically controlled motors follow different architectures. Confirm the motor label, unit diagram, required microfarads and voltage rating before testing or replacing anything. Capacitors can retain hazardous charge after power is removed. Qualified technicians disconnect power, verify absence of voltage, discharge the capacitor by the approved method, isolate it as required and compare the measured capacitance with the exact specification. Never use a stick to push start a blade and never substitute a capacitor because its case looks similar. A breaker, disconnect, contactor, relay, connector or loose terminal can interrupt power or create heat. Measure supply on both sides of the switching path before and during the failure, using rated instruments and safe procedures. If voltage disappears before speed does, trace upstream. If correct supply remains at the motor while the command is present and speed collapses, the evidence points farther downstream. Repeatedly resetting a tripped breaker is not diagnosis. When the control command drops first, do not condemn the motor. Check the requested mode, thermostat signal, time delays, relay or contactor drive, control board status, and documented safety inputs. A pressure switch or other system protection may intentionally remove the fan or compressor command. Read the unit's fault history and wiring diagram rather than bypassing the device that interrupted operation. With all energy isolated and stored energy controlled, a qualified inspection can check for debris, blade to shroud contact, damaged guards, loose hubs, bearing roughness and abnormal shaft play. Drag raises torque demand and current, which can become heat and a later trip. A rubbing mark or rough hand rotation is evidence. Spinning the blade on an energized unit is not a safe test. The fan belongs to a complete refrigeration and air distribution system. A blocked condenser coil, recirculating hot discharge air, a loaded indoor filter, frozen coil or abnormal pressure can change operating conditions or trigger protective logic. Correlate fan speed with coil condition, airflow, pressure events, and compressor state. Fix the system cause instead of repeatedly replacing the same fan part. Record which fan stopped, operating mode, start and stop times, restart delay, command state, supply voltage, current, temperature trend, sound, visible obstruction and fault codes. That packet lets a technician distinguish thermal cycling, a motor-specific capacitor issue, power interruption, control dropout, mechanical drag, and system protection. The most useful next step is simple: safely record the moment it stops, then match the evidence to the exact unit diagram and motor specification.